Recorded at the Mandito Amplification Annex of Maggio Music Center in Brooklyn, New York. Today at Mandito Amplification, we have a 1990 Marshall JCM 900 50-watt high gain dual reverb guitar amplifier combo. It's equipped with two ECC 83 or 12 AX7 preamp tubes, one ECC 83 12AX7 phase splitter tube, and in the power amp section, we have two EL34 power tubes. This amplifier has one 12-inch speaker. It was originally equipped with a Celestion G12T-75 8-ohm speaker. This particular amplifier has an 8-ohm Celestion G12 Classic Lead 80. Looking down on the top of the cabinet, someone has placed large washers on the screws that hold in the amplifier chassis. This handle also looks like it's been replaced, but at least the finishing washers and screws for the rear panel appear to be original. So this amplifier has definitely been opened up before, and I'm not certain what we're going to encounter when we get inside. The main reason that this amp was brought to me was because the Channel B reverb and master volume potentiometers were broken. It needed two new potentiometers and two new knobs. This unit was built on April 19th, 1990 at Jim Marshall Products Limited in Bletchley, England. Here is the factory tag signed by some of the proud people who built this amplifier, as well as the tags on the circuit boards. Here is a clear view of the internals of this amplifier, and upon first glance, it seems really nice. Nothing is burned or discolored. There doesn't seem to be any alterations to the circuit. Well, that is until you get to resistor number 30, which is in upside down, standing taller than everything else, and kind of tagged on top of another resistor, held in with a couple of globs of solder. Why would someone do this? Well, we'll find out later on. Our customer wanted a new tube set, so he chose these JJ ECC83S tubes for the preamp and phase splitter, and these nice Tung Sol EL34B tubes for the power amp section. I recommended to the customer that we change these original can style electrolytic capacitors, as well as this axial electrolytic capacitor on the front circuit board. We used F&T brand capacitors, but I had to go with a 47 microfarad at 500 volt axial capacitor because when I performed this work at the beginning of 2022, there were supply chain issues. Here are the can-style electrolytic capacitors that we are going to replace. Before proceeding, I suggest that you take a photograph or draw yourself a diagram. You need to desolder all of these connections, unscrew the capacitor clamps, remove the old capacitors, put the new ones in place, tighten those screws, place all of the wiring back on the proper terminals, and then solder all connections. Next, we are going to change these broken potentiometers. In order to do this, we need to pull out the entire front circuit board. So the first step is to remove the nylon nuts from the foot switch and input jack. Then we need to remove all the knobs from the potentiometers. Then we need to unscrew the nuts and remove the nuts and washers from the potentiometers that have them. Next, we go on the inside of the chassis, and at the rear of the circuit board, we have two nylon standoffs. We need to depress the tip on these nylon standoffs gently with a long nose pliers and then kind of just pop that up. From there, we should be able to pull the entire circuit board out of the front fascia and flip it over. Here I have circled the legs of the potentiometers that we need to desolder. I desoldered them, but then I actually needed to nip the ends off in order to be able to safely pull them through the circuit board. Unfortunately, I scratched the conformal coating on the board a little bit. I placed in the new potentiometers. The VR9 position reverb potentiometer is a 220K linear taper, and the VR10 position master volume potentiometer is a 1 mega ohm audio taper. I bent the legs over slightly so that they would make a little bit more contact with the traces. I put some flux on the legs and then I soldered them in place. I followed up by touching up the scratches with a little bit of green paint. Next, we are going to change this axial electrolytic capacitor on the front board. I have desoldered it from the board and removed it. I placed a piece of 3M VHB double stick tape for the new capacitor. I shaped the leads on the new capacitor, installed it into place, and then I soldered it to the board. Now I have placed the front circuit board back into the chassis, installed and tightened all of the nuts, and then installed the new knobs. Okay, we've made tremendous progress. We've got it all back together. We've got the old tube set back in, and now we're going to test it because the amplifier came into my shop functioning. It didn't function perfectly. This was broken off. This one was messed up also. Okay? But it functioned. It made a little bit of noise. That's why I changed the filter capacitors. So now, these two potentiometers are not going to affect the overall function of the amplifier. I would just as easily be able to use this channel. What I'm concerned about is that after I changed these two capacitors, I tested it and the amp worked. So now I need to test to make sure it works after changing this capacitor. So to eliminate any other variables, I knew the original tube set worked, so I put the original tube set back in, and now I'm going to test this, and then these two new potentiometers. I was testing out the amplifier and everything seemed to be working just fine, but after flipping this half power switch, the power tube started to draw way too much current and overheat. I ran into a situation where the power tubes were red plating, and the potentiometer adjustment here, it just didn't do anything at all. And then when I measured the bias voltage there was none. So there was no negative DC voltage to the grids, and then as I went back, there was no negative DC voltage anywhere in this bias circuit, all the way until I get up to this little brick. This little brick is an X-class capacitor, a 0.047 microfarad at 250 volt capacitor, and it was not functioning at all. So I tacked in a 0.047 at 400 volt film capacitor on the other side of the circuit board, and then I was able to get bias voltage. Now it's 2022. We are having severe supply chain issues. I wasn't going to be able to get this X-class capacitor, so I instead installed a 630 volt Mallory 0.047 microfarad film capacitor. Now we need to address the question about resistor number 30. Why was this modification done? It's possible that capacitor number 15 was failing slowly, and that this was the stopgap measure necessary to raise the bias voltage enough for the amp to function properly. Now in the future, the gentleman who owns this amplifier may want to complete this restoration and change the rest of these random electrolytic capacitors that you see here. And these are some radial ones popping up, standing up off the board here. You've got a couple of them here in the bias power supply. So let's let him try this out, let him use it. Let's see if he wants to invest any more money and time into this amplifier. Got another one here. Now, I replaced these. Everything was functioning. I didn't notice that the tubes were red plating when the amplifier was brought to me. It was brought to me with these broken potentiometers, and he wanted new tubes, and he wanted me to freshen it up and just check everything out. So, like I said, nothing was burned. The only thing suspect was this tagged-on modification to the bias power supply where someone put a resistor here in parallel. Don't know why, but everything seems to work fine. It is possible that this board was originally for 5881 tubes, and that was the modification necessary for it to work with the EL34 tubes. I'm not exactly sure. That could be. So now what I'm going to do is I'm going to reassemble this into the cabinet, and then we're going to test it out and see if the reverb works properly, because I did change this as the reverb potentiometer here for channel B, or was that A? I was channel master channel B. So that was the reverb potentiometer for master channel B. This is the volume that I changed here. So, okay, I'm going to put it all back together. We're going to check it out and see if it works after that. This Marshall JCM 900 partial restoration and refurbishment project was a complete success. The owner is supposed to pick this amplifier up today, and today is April 19th, 2022. It is the amplifier's birthday. It was, well, the date on it for final inspection is 4/19/1990. So happy birthday, Marshall JCM 900 4501 combo. I wish you many good years. And if the owner, Andy, does not show up today, maybe we'll try to do a brief audio demonstration, but I'll just let you know it's loud and louder. And that's all you really need to know. Sounds good and really loud. Thank you very much for watching. Please take a moment to like our video and to subscribe to our channel. You can give us a call, write us an email, or check us out at menditoamps.com. We will have more videos coming to you very soon from the Mendito Amplification Annex of Maggio Music Center in Brooklyn, New York.